For a series circuit, the equivalent resistance of several resistors is equal to the sum of the individual values. Now let's apply this to an example. So let's draw a circuit that has 3 resistors in series. R1 is 25 ohms, R2 is 45 ohms, and R3 is 10 ohms. And the total voltage in the circuit is 50 volts. Let's also draw a chart of all the things that we are going to want to find for this circuit. So pressure difference for resistor 1, flow rate in resistor 1, and then value of resistor 1. And make a row for each component. And then also make a row for the total values. So the total pressure difference, that's going to be here at the battery. The total flow rate and the total resistance. And by total resistance, we mean if you were going to replace all the resistors with just one resistor and have, the same basic flow rate in your circuit, what value would that resistor have? So what we need to do is find the equivalent resistance of these resistors. This is a series circuit, so we can find the equivalent resistance by adding up the values of the resistors. So putting in the value of each one, 25 ohms plus 45 ohms plus 10 ohms, which equals 80 ohms. And sometimes I will label this with the subscript of which resistors I have combined. So here I've combined resistors 1, 2, and 3. So this is not 123. This means the combined resistance of resistors 1, 2, and 3 is 80 ohms. And I can now put my equivalent resistance in my chart. And I'm actually going to go back and fill in the other values that I know. I didn't do that yet. And the total resistance is 50 volts. So what this means is that an equivalent circuit would be this. We could replace all of those resistors by just one resistor, and it would have the same flow rate as the combination of those 3. Okay, so we found the total resistance. Now we want to find the rest of the values, and so I'm going to show you how to think through a circuit and figure out the rest of these values. So anytime you know 2 of these quantities in one row, you can find the third one because we have this definition of resistance, which is resistance equals pressure difference over flow rate. We can apply that to any individual resistor, or we can apply it to the total of the circuit. So let's apply this to the total of the circuit, and it's always good to label what you're doing. So I'm going to find the total current, and I'm going to write this relationship in this form just because it's a habit. So 50 volts equals the total flow rate times the total resistance of the circuit, and that gives me a total flow rate of 0.63 amps. And fill that in your chart. And then ask yourself, okay, where is this happening in the circuit? Well, total flow rate is always going to be happening in that wire right after and before the battery. So we know it's happening in these wires. Is it happening in this wire? It is, because there are no branches. So the flow rate here, which is 0.63 amps, has to be the same as the flow rate here, which is 0.63 amps. Has to be the same as the flow rate here, which is 0.63 amps. So the flow rate is the same everywhere in a series circuit. Does that help me figure out any of these values? It does, because these are the flow rates through each resistor, and we just said that in a series circuit it's the same. So we know these. Okay, and now that you know all of the flow rates, you could find each of the pressure differences. So to find the pressure differences, let's take a look at one of these at a time. Let's take a look at resistor 1. Let's find the pressure difference across resistor 1. So applying our relationship to that resistor, we find that the pressure difference is 16 volts. And then we can find delta V2 the same way. So why don't you go ahead and calculate that. And for the third pressure difference, we could do the same thing. We could apply this equation again, but I'm going to show you another way to find it because you want to be able to look at these problems multiple ways, and sometimes you might need this other way of finding it. This last way that I want to point out is that you can actually find this pressure difference not only from using this relationship, but you can find it by using these. Just looking at the other pressure differences, you can find this value. And in order to point that out, I'm going to quickly color code this circuit. So the high pressure is red, low pressure is blue. And for sake of speed here, I am not going to actually pay attention to the values and decide whether to use yellow, orange, or green. I'm just going to pick randomly to use orange and green. So it might not be that maybe it should have been yellow and green, or maybe it should have been orange and yellow, but just something intermediate in there. And what I want you to see is that, maybe I can also draw over here the range of these values. So blue is the lowest, red is the highest, and then we've got a wire in there that's at orange pressure and a wire that's at green pressure. So from red to blue, we can tell is 50 volts. So this whole thing, red to blue, is a pressure difference of 50 volts. Now, what happens from red to orange? Across resistor 1, we know red to orange is 16 volts. That's the pressure difference from red to orange. From orange to green, that's across resistor 2. We know that is a pressure difference of 28 volts. Well, what is the pressure difference across resistor 3? It has to be the rest of the 50 volts. Okay, so all of these pressure differences have to add up to the 50 volts. And you actually saw that when we did our circuit measurements with the voltmeter, that in series those pressure differences add up. So the remaining pressure difference has to be 6 volts. Okay, and you can check that with this relationship that delta V3 equals I3 R3. So let's just check it. 0.63 amps times 10 ohms equals 6.3 volts. So have some rounding going on within the problem, but you can see there are two ways to find this pressure difference.